Hello viewers, in this lesson we'll be discussing about moment generating function MGF. If you are new to this channel, kindly make sure you subscribe, you like and you share the videos with your colleagues who are also going to find it helpful. Without wasting much of our time, let's move into what we have in this lesson. Moment generating functions MGF, moment generating function. So when we're talking about moment generating function, what I was saying in essence, what has been implied, moment generating, that is, moment generating function MGF is a function that is used to generate moments. In the last lesson we discussed about moments, the first moment and the second moment, and generally the act moment of a random variable about its origin. So once you have your moment generating function, you can use that moment generating function to derive the moment. That is why it is called moment generating function. Moment generating function. So we make use of moment generating function to generate moment, which is an expected value, which is a mathematical expectation. So the moment generating function is a function of t. Take note, moment generating function, the moment generating function of a random variable x is a function of what? Is a function of t. And the moment generating function of random variable of x for probability function is different from that of probability density function. So for probability function, it is derived by having the summation of exponential tx. Please take note, exponential tx multiplied by what? Multiplied by f of x. Multiplied by f of x. Multiplied by f of x. It is more of taking the expectation of what? Of exponential tx. Exponential tx. So for probability density function, the moment generating function of random variable x, which is a function of t, is equal to the integral from minus infinity to infinity of what? Of exponential tx multiplied by f of x dx. F of x dx. So that's the formula in which we use to generate the moment generating function. So if it can be asked to firstly generate the moment generating function of a random variable x, then you can now be asked to use that MGF, that is moment generating function, to determine variance or determine first moment, second moment, determine variance and standard deviation, as the case may be. So without wasting much of our time, let's move to an example. Example 1. So this example says, find the moment generating function MGF of the random variable x whose probability density is given by, this one is the probability density, is given by, whose probability density is given by f of x equals to exponential minus x for x greater than 0 and 0 elsewhere. 0 elsewhere. So we have to find the moment generating function of that probability distribution. Solution. So that's we are beginning f of x, and as you can see, it's a probability density function. So your moment generating function f of t for probability density function, which is the integral, we are recalling this. Recall that this is the integral from minus infinity to where? To infinity of what? Of exponential tx multiplied by what? Multiplied by f of x dx. So for 0 elsewhere, you then assume that it is from what? From minus infinity to where? To 0. And this one will be for what? From 0 to infinity. So here we have what? From minus we have minus infinity to here to 0 times of exponential tx multiplied by f of x, and f of x for that boundary is 0. That's times what? Times 0 dx plus the integral. Here we ended at 0, so here we starting from 0 to infinity of what? Of exponential tx multiplied by f of x, and f of x for that condition is what? Exponential minus x. Exponential minus x. Exponential minus x dx. Exponential minus x dx. You know, since this is 0, automatically everything here is going to be 0, so you will be left with this. So here we have what? So this becomes 0. Here we have the integral of 0 to infinity of exponential tx multiplied by exponential minus x dx. And as you can see, here we are having what? We are having we can apply our law of indices because we are having two common variable here, which is exponential. So if we apply a law of indices, the sign between them is multiplication, so you'll be adding their index. You'll be adding their index. So here we have what? The integral from 0 to infinity of what? Of exponential tx minus x dx of exponential tx minus x dx. And as you can see, x is common. X is common between the two, so we can decide to bring out x. You can decide to bring out x. So here we have what? Here we have the integral. We have the integral from 0 to infinity of exponential x into t minus 1 dx. T minus 1 dx. T minus 1 dx. And you can also see there we need to solve it further to make it more easier for us when introducing our boundary condition. You know, it won't be easy for you to solve for the value of exponential infinity. It will only be easier for you to solve for the value of exponential minus infinity as we have been doing before. So you make it to be possible for you to have exponential minus infinity. And in this situation, will you be having exponential minus infinity when introducing the boundary condition? No, because when you put your infinity here, everything becomes exponential infinity. So for us to have exponential minus infinity, we need to introduce a negative into this expression. So if you introduce a negative into the expression, you have the integral from 0 to infinity of exponential minus x. But since minus is already here, and we don't want to change the value of this expression, so automatically the expression within the bracket is going to be changed. The expression is going to change to 1 minus t dx. So let's verify if that expression still remains the same. If you use your minus to open this bracket back, minus times 1, it becomes minus 1, which is there, minus times minus t, it becomes plus t, and that becomes x into t minus 1. So this expression is still what we have here. It's still what we have there. So we just have to do that for us to be able to solve that problem. If not, we won't be finding it easy to solve that problem. So since we have been able to break everything down into this, so we can now introduce our boundary condition. So introducing our boundary condition, first we need to integrate. We haven't integrated this. So let's integrate before introducing our boundary condition. So by integrating that, from your normal rule, you understand. If you want to integrate this, how do you go about it? How do you go about that? If you want to integrate this, you differentiate the index, then you divide everything by the result of that differentiation. So if we differentiate this, what we differentiate minus x into 1 minus t, what will we be having? we should be having minus 1 minus t, minus 1 minus t. So we will be having, so your result should be what? Exponential minus x, exponential minus x into 1 minus t all over minus into 1 minus t, minus into 1 minus t. So that's going to be our value for that. That's going to be our value for that. So we can decide to rearrange this. We can decide to rearrange this. So if we decide to rearrange this, what will be happening? So we can say this is what? This is 1 minus 1 over 1 minus t, minus 1 over 1 minus t into exponential minus x into 1 minus t. Our boundary condition, don't forget, from 0 to where? From 0 to infinity. From 0 to infinity. So now let's introduce our boundary conditions. So by introducing our boundary condition, let's have a bigger bracket here. So here we have minus 1 over 1 minus infinity over 1 minus infinity into exponential minus infinity. Sorry, this is 1 minus t. 1 minus t, because we are replacing for x and not, we are replacing for x and not t. Don't forget we integrated with respect to x. So that will be exponential minus infinity into 1 minus t into 1 minus t, close the bracket, minus 1 over 1 minus t into exponential minus 0 into 1 minus t into 1 minus t, then close the bigger bracket. So let's simplify this. You know, everything here becomes minus s minus infinity, like as we wanted it to be. So and anything exponential minus infinity is going to give us 0. So everything and 0 multiplied by this, everything becomes 0. Or likewise this, everything here becomes 0 because 0 times anything is what? 0. So I left with exponential 0 and anything raised to power 0 is what? Is 1. So automatically everything here becomes 1. So we are left with what? Minus 1 over 1 minus t. But don't forget, we are left with what? Minus outside here. So minus times this minus will become plus. So finally we have what? 1 over 1 minus t. 1 over 1 minus t. So automatically the moment generating function of the random variable x for that distribution is equal to 1 minus t, is equal to 1 minus t. So we'll be moving to the next example on this. But recall, you should remember that I told us at the beginning of the lesson that the main function of moment generating function, the main use of moment generating function is to what? Is to determine moment, is to generate or derive moment. So if you want to use your moment generating function to determine the act moment, act can be anything, it can be 1, it can be 2, it can be 3, the act moment of a random variable x, the act moment of a random variable x, mu prime r, mu r prime is equal to what? Is equal to the derivative, please take note, is equal to the derivative of the moment generating function of t by the number of what? To the degree of r, to the degree of r with respect to what? With respect to the t to the degree of r, to the degree of r, limiting t to what? Limiting t to 0. Limiting t to 0. Limiting t to 0. So that's the formula you need to use to generate our moment from our moment generating function. So that automatically tells you that if your r is 1, that is the first moment, automatically the first moment mu 1 prime will definitely be what? The n, because r is 1, the n the mt taking t to be what? To be 0. So your second limit mean 2 prime will be what? T square, that's the second derivative. Square t dt taking t to what? Taking t to 0. Taking t to 0. Just take note of that. Take note of that. So we are able to determine the formula we need to use to generate our moment from our moment generating function. So now let's move to an example in which we can apply that concept. So this example says, given that x has the probability distribution f of x equals 1 over 8 into 1 over 8 into 3 1 over 8. So it says, given that f of x, given that f of x equals 1 over 8 into 3 combination x. You know, combination can also be represented in this way. Combination can also be represented in this way. So please don't make the mistake of thinking there's a division between 3 and x. So this is the way the question was given. This is the way the question was given. So we are not having division. So it is combination, 3 combination x. So your 3 combination, your n combination r, don't forget, your n combination r can be written as what? Can be written as, your n combination r can be written as what? N r. Remember, so that the same thing applies to this. So that's your probability function for x equals 0, 1, 2, 3, and that tells you that this is a probability function since x is what? Is discrete. Is discrete. First off, find the MGF of the random variable and use it to find mu1 prime, comma, mu2 prime, comma, and sigma squared, and that's what? That's variance. Solution. The first example we did was on probability density function, and this one is on what? Probability function. And recall that the moment generating function of x, of random variable x, for probability function is equal to what? Is summation of what? Of exponential tx and what? Multiplied by what? F of x. Multiplied by f of x. So that tells you that here we'll be having what? We'll be having exponential, we'll be having summation of exponential tx multiplied by what? Multiplied by 1 over 8 into 3 combination x. Into 3 combination x. Into 3 combination x. So let's bring in those values one after the other. That is 0 to 3. So the first one is going to be what? The first one is going to be exponential t into 0. You know, here we have x, replace it with what? Replace it with 0 times 1 over 8 into 3 combination 0. Combination 0. Or let's write it in the standard way. 1 over 8 into 3 combination 0 plus exponential t into 1 multiplied by 1 over 8 3 combination 1 plus exponential t into 2 multiplied by 1 over 8 3 combination 2 plus exponential t into 3 multiplied by 1 over 8 times 3 combination times 3 combination 3 combination 3 and 3 combination 3. So we can simplify this further. We can decide to simplify this expression further. So if we simplify this expression further, what we're going to do, 1 over 8 is common for everything. So we can decide to bring out 1 over 8 for all the values, and we know here we have 1 over 8 into, here we have exponential t raised to power 0, and we know that anything raised to power 0 is going to give us what? Anything raised to power 0 is going to give us 1. Anything raised to power 0, t times 0 is what? Is 0, and exponential 0 is going to be what? Is going to be 1. And we also know that here we already have 1. Without considering 1 over 8, remember we have brought out 1 over 8, and we also know that 3 combination 0 is equals to 1. You can check that with the calculator. 3 combination 0 is equals to 1. So here we have 1 times 1, and that's going to be what? That's going to be 1. That's going to be 1 plus, similarly, t times 1 is t. You will be left with what? Exponential t. And we know that 3 combination 1 is going to be giving us 3. So here we are having 3 times exponential t. That will be 3 exponential t. Don't forget that 1 over 8 has been brought out. So we don't need to consider that 1 over 8. So this one will be what? This one will be 3 exponential t. 3 exponential t. Similarly here, we have t raised to power exponential t times 2, that will be what? Exponential 2t. 3 combination 2 is also 3. 3 combination 2 is also 3. You can take that with the calculator. So we are having what? We will be having 3 exponential 2t. 3 exponential 2t plus the last one we have exponential t times 3, that will be exponential 3t. Exponential 3t times 3 combination 3. 3 combination 3 will give us 1. 3 combination 3 will give us 1. So 1 times exponential 3t is going to be what? Exponential 3t plus exponential 3t plus exponential 3t. So all the 1 over 8 has been brought out. So we brought out all the 1 over 8. We brought out all the 1 over 8. So the next thing we need to do, we need to break this down. We need to factorize this. We want to reduce this expression by factorizing it. So to make it easier, to make it look more easier, it may be looking complex this way. So what about we represent exponential t with an arbitrary variable or arbitrary letter. So let's say let exponential t equals, let's say, s. So automatically we have 1 over 8 into 1, or let's say 1 over 8 into 1 plus 3s. You know exponential t equals to s, right? Plus this is going to be, if you want to write this, it's going to be 1 plus 3 exponential t plus 3 exponential t times 2, right? Plus exponential t times 3. So automatically exponential t is s, exponential t is s, exponential t is s. Automatically this is going to be what? 3s squared. 3s squared plus s cubed plus s cubed. So if we arrange this, it becomes what? 1 over 8 into s cubed plus 3s squared plus 3s plus 1. And as you can see, this is looking like a polynomial expression, And you know, the binomial expansion of q of 1 plus s or s plus 1 is going to be giving us this expression. So we are going to be breaking this down into that cube. So here we have what? 1 over 8 into s plus 1 raised to power what? Raised to power 3. So you can expand this using your binomial theorem. Then if you expand this using binomial theorem, you're going to have this. And if you don't want to use your binomial theorem, you can write this in 3 places, then multiply one with the other to expand it, then you are going to get this. If you are familiar with factorization, or you are familiar with quadratic or polynomial expression, once you see this expression, you already know that the final factors are going to be what? S plus 1. So we are going to break this down, but don't forget, we substituted exponential t for what? For x. So let's return our exponential t. So here we are having what? 1 over 8 into 1 plus exponential t raised to power what? Raised to power 3. So we have been able to simplify our moment generating function. So our MGF, our moment generating function for random variables, is giving us 1 over 8 into 1 plus exponential t all raised to power what? All raised to power 3. All raised to power 3. So we will have to find our first moment and our second moment for us to be able to determine our variance. So what we need to do to get our first moment v1 prime, which is equal to the first derivative. I already given us the formula, okay, and the round off. The first derivative of m of t, with respect to what? With respect to t, taking the limit of t to be what? To be 0, taking the limit of t to be 0. So we can easily differentiate this. So we want to differentiate this expression with respect to t. 1 over x is a constant. So how do we go about this? You know, this is function of a function. So you can apply your theory. You can use your theory to solve that. So using our theory, how do we go about this? So you can say let u equals 1 plus exponential t. I'm just trying to take us back to our theory, which is a very simple approach. 1 plus u equals to 1 plus exponential t. You know, the u dt is going to be what? 1 will become 0. The dimension of the constant is what? Is 0. This will become 0. And the dimension of exponential t. The dimension of exponential t is also what? Is still exponential t. But don't forget, we have replaced this with what? With u. So we have uq. So the derivative of uq. So let's say m equals to what? M equals to uq. Without considering this constant, I just try to remove this constant for now. We are going to be returning the constant back later. So m, let's say m is equals to what? Is equals to uq, because we said u to be what? 1 plus exponential t. M equals to uq. Automatically the m du will be what? 3u squared. The m du will be what? Will be 3u squared. So the core, automatically the m dt will be equal to what? The m du times du dt. So change, you know, if du cancels du, it returns back to the m dt. And the m du give us what? 3u squared multiplied by our du dt give us what? Exponential t. Exponential t. So what will be our u? We already know our u because we replaced 1 plus exponential t with what? With u. So automatically we have what? 3 into 1 plus exponential t squared times what? Exponential t times exponential t. So that's the derivative to that. But don't forget, we still have the constant 1 over 8 outside. So let's return back our constant. So we've been able to do this with our chain. We've been able to get this with our chain. So we can now calculate our first moment. We can calculate our first moment. So our first moment, which is v1 prime, is now going to be what? Is now going to be 3 over 8. Don't forget, we brought out 1 over 8, and we have 3 here. So that's going to be what? 3 over 8 into 1 plus exponential t squared multiplied by exponential t multiplied by exponential t. Taking t to what? To 0. So automatically becomes 3 over 8 into 1 plus exponential 0 squared times exponential 0 times exponential 0. So automatically becomes what? 3 over 8. Here we have what? 1 plus anything square 0 gives us 1. 1 plus 1 squared multiplied by 1 multiplied by 1. Automatically everything becomes what? 2. 2 squared becomes what? 4. So automatically here we have what? 3 over 8 times 4. 4 here 1, 4 here 2. So the final answer becomes what? 3 over 2. 3 over 2. So that's our first moment. We also have to calculate our second moment, mu 2 prime, which is going to be the second derivative of your what? Of the moment generating function m of t with respect to what? With respect to t. That's the second derivative. The square with t squared. So how do we do about that to get, you know, our when we did the first derivative resulted into this. The first derivative resulted into this expression. So the second derivative will be solved similarly in that way. Second derivative will be solved similarly in that way. So we can decide to apply our product rule. We can decide to apply our product rule to find our second derivative. And in this situation 3 over 8 is a constant. 3 over 8 is a constant. So we just decide to treat that as a constant. So for the sake of those who don't have the idea of the product rule, so I'll be solving that using the product rule. So the second derivative of your moment generating function will be the derivative of your moment of your first moment. You know you have differentiated the moment generating function once to get your first moment. So to get your second moment, you need to differentiate that first moment again. You need to differentiate that first moment again. So your second moment is going to be that constant. Please bring out the constant. Bringing out the constant into the derivative, the first derivative of the first moment, because you have differentiated the first moment before. So that was 1 plus exponential t, 1 plus exponential t squared into exponential t into exponential t into exponential t. 1 plus exponential t squared into exponential t. 1 plus exponential t squared into exponential t. However, we can decide to expand this. We don't want to go through the process. If you don't want to go through the process of using product rule, you can decide to expand this. Before differentiating. So to make it easier, let's quickly expand. So we have 3 over 8 into derivative of. So if we expand this, what are we going to be having? Let's expand this first. You know, we have to expand this first. This in 2 places. We'll be having 1. We're having 1 plus 2 exponential t plus exponential 2t plus exponential 2t. So if you expand it, this is what you are going to get. If you expand that, that's what you are going to get. You can try it out in your leisure time. But you still have exponential t here. Don't forget. You still have exponential t here. So we are going to be using that exponential t to also open the bracket. We have 3 over 8 here. Derivative of this. So this gives us exponential t times 1. We have exponential t. Exponential t times 2 exponential t. Exponential t times 2 exponential t. That will give us 2 exponential 2t, because 2 is a constant and we have exponential t times exponential t, then t will be adding the t. That becomes 2t. That will be 2 exponential 2t plus 2 exponential 2t times exponential t. That will be exponential 3t. Exponential 2t times exponential t. That will be exponential 3t. So we have been able to expand this. So we can now easily differentiate instead of going through the steps of product rule. And during the course of product rule, we might even decide to use chain rule again, because that's the function of the function multiplied by the product. So this becomes more easier. So here we have what you can now differentiate. You have 3 over 8 as a constant. So differentiating exponential t, it is t exponential t. Don't forget, we are taking t to what? To 0. Differentiation of exponential t gives us exponential t. Differentiation of 2 exponential 2t will give us the trick we are usually use. You differentiate the exponent, which will give you 2. Then you what? Then you use it to multiply. If it is integration, you use it to divide. If it is differentiation, you use it to what? You use it to multiply. So this automatically gives us what? Plus 2. You know, when you differentiate 2t, it gives you 2. 2 times that 2, that's 4. Plus 4 exponential 2t plus 4 exponential 2t plus, here we have 3t. Differentiate 3t gives you what? Gives you 3, and that's automatically what? That's automatically exponential. That's automatically 3 exponential 3t. 3 exponential 3t, taking t to what? To 0. So at this point, we can easily substitute in our t. We can easily substitute in our t. So now let's substitute in our t easily. What are we having? We have what? 3 over 8 into exponential 0 plus 4 exponential, it's going to be exponential 0 as well, because 2 times 0 is 0. Exponential 0 plus 3, likewise this one is going to be exponential 0. So automatically we have what? 3 over 8 into this, anything raised to power 0 give you 1. This becomes 1 plus anything raised to power 0 gives you what? Gives you 1. That will be 1 plus 4. 1 plus 4 plus anything raised to power 0 gives you 1 plus 3. So 4 plus 3, 7 plus 1, 8. So we have what? 3 over 8 times 3 over 8 times what? Times 8. 8 cancels 8. I left it what? I left it 3. So the second moment it will give you what? It will give you 3. The answer to the second moment is what? Is 3. So we have been able to get our first moment and we have been able to get our second moment. So we can now use those two values to calculate our variance, which is sigma squared. So we call sigma squared is equals to what? Is equals to second moment minus 12 first moment. And second moment is what? Is 3. First moment, our first moment is what? Our first moment is 3 over 2. Our first moment is 3 over 2. That's 3 over 2 squared. 3 minus 3 over 2 all squared. And we do that very well. We should be having what? We should be having 3. We should be having 3 over 4. We should be having 3 over 4. We should be having 3 over 4. Here we know we have this will become 3 squared over what? Over 2 squared. And that's automatically 9 over 4. So 3 minus 9 over 4. We are having 3 over 4. So that's about that example. So let's move moving on to the next example on moment generating function MGF. Example. So this example says find the MGF of the continuous random variable x whose probability density is given by, this is one of the probability density function, whose probability density is given as f of x over f of x over what? 1 0 1 for 0 less than x less than 1 and 1 0 elsewhere 0 elsewhere, and use it to find first moment, that is mu 2 prime, mu 1 prime, and variance sigma squared. Solution. So we know that is the probability density function. So recall for probability density function that the moment generating function m of t is equals to what? Is equals to the integral from minus infinity to infinity of exponential tx f of x dx. F of x dx. So for this one, you know we have minus, this will be going to be, for 0 is definitely going to be minus infinity to 0, minus infinity to 0, minus infinity to 0, and here we have exponential tx times f of x for that range, that's 0 dx, plus, you know, this is ending at 0, so this is going to be starting with 0. 0 to where? 0 to 1. This is the condition is 0 to 1. 0 to 1 exponential tx times the f of x for that range is what? Is 1 times 1 Yes. The mathematical integration of 0, we give you what? We give you 0, so this becomes 0. We are left with this. We are left with this. 0 to 1. Here we have what? Exponential tx dx. Exponential tx dx. So integrating exponential tx, what do we have? If we integrate exponential tx, just differentiate the index. If you differentiate the index, you have what? You have t. If you differentiate the index, you have t. You're dividing the solution like that. You have what? Exponential tx over t. Exponential tx over t from 0 to 1. From 0 to 1. From 0 to 1. So introducing that boundary condition, what do we have? Introducing the boundary condition, we have exponential t into, we are replacing x and not t. Exponential t into 1 over t minus exponential t minus exponential t into 0 over t. So this becomes exponential t. So we are left with what? We are left with, and you know, t is common to both, so we can factorize out 1 over t. So bringing out 1 over t into exponential t. Exponential t minus exponential t times 0. That becomes exponential 0. And exponential 0 will give us what? Will give us 1. So we have exponential t minus 1. Exponential t minus 1. Exponential t minus 1. So automatically the homogeneous function for that is going to be what? 1 over t into exponential t minus 1 into exponential t minus 1. And as you can see, we are going to be differentiating. We are going to be differentiating to get your first moment, your second moment. To get your first and second moment, we are going to be what? We are going to be differentiating this expression. And you can see this expression is in form of product. So the differentiation might become complex for you later on. So to make it more easier, to make life easier for you, is advisable, you can break this down into Maclaurin series. You can break this down Maclaurin series, Taylor series. You might have come across that before. So, and this is even a simple, which is the basic Maclaurin expansion, exponential t. Majority of us have come across that before. So remember that the Maclaurin series or expansion of exponential t is going to be giving us what? Is going to be giving us 1 plus t plus t squared, 1 plus t squared over 2 factorial plus t cubed over 3 factorial plus t raised to power 4 over 4 factorial plus dot. Make sure you indicate that triple dot, it's an infinite tree. minus 1. Don't forget we are having minus 1 here. As you can see, this 1 and this minus 1 can cancel out. So you'll be left with what? 1 over t into, if you decide to bring out that minus 1 in front of this one, it is everything that subtracting each other. So you'll be having what? You'll be left with t plus t squared over 2 factorial plus t cubed over 3 factorial plus t raised to power 4 over 4 factorial plus dot. It's an infinite series. Similarly, you can use 1 over t to multiply the series. You can use 1 over t to multiply the series. So using 1 over t to multiply the series, you will be left with what? 1. I will be left with 1 over t times t. We give you what? We give you 1. So we left with 1 plus, we have 1 plus t t squared over 2 factorial will be giving us, here we are having t over 2 factorial, t over 2 factorial plus t cancels t cube, will be left with what? T squared, t cube over 3 factorial plus t cancels 1 of t raised to power 4, will be left with what? Sorry. So similarly you can try to use 1 over t to multiply this expression. Right? Decide to use 1 over t to multiply this expression. So using 1 over t to multiply this expression, you'll be left with what? 1 plus 1 over t, 1 over t cancels t, you are left with what? You are left with 1 over t multiplied by t squared, it will cancel 1 of that, you'll be left with t plus t over 2 factorial plus t 1 over t multiplied by t cube, you'll be having what? T squared over what? Over 3 factorial plus t raised to power 3 over what? Over 4 factorial plus dot. So that's about that expression, and you can decide to write it further. You can write it up to 5. If you write it up to 5, you'll be having what? You'll be having, in this same pattern, it will be what? T raised to power what? T raised to power 4 over what? Over 5 factorial. So we have been able to get our moment generating function in form of series. So we can now determine our first moment. So determining our first moment, what do we have? That's the first derivative of your moment generating function. So we want to differentiate this once. So if you differentiate that gives you what? That gives you, differentiate 1 becomes what? 0. If you differentiate t over 2 factorial, so 1 over 2 factorial will serve as a constant. You just focus on t. So that gives you what? That gives you 1. So this becomes what? This becomes 1 over 2 factorial, 1 over 2 factorial plus, if you differentiate this, it becomes what? 2t over 3 factorial plus 3t squared, 3 times t minus 1 becomes 3t squared over 4 factorial plus dot. But don't forget, you are setting t to what? To 0. You are setting t to 0 for you to get the first moment. So plugging in your 0, automatically everything here will become what? It becomes 0. You will be left with what? 1 over 2 factorial. And 1 over 2 factorial, 2 factorial is what? Is 2. 1 over 2 factorial will become what? 1 over 2. So the first moment will give you 1 over 2. The first moment will give you 1 over 2. So to determine our second moment will definitely be the derivative of the first moment. So we differentiate this once again, then you set it t to what? You set t to 0. So differentiating this once again, 1 over 2 factorial will become 0 because it's already a constant. Then this will become what? 2 over 3 factorial. This becomes what? 2 over 3 factorial plus this becomes what? 2 times 3, that's 6 times t. So that's 60 plus 60 over what? Over 4 factorial plus dot. Everything will still become 0. Setting t to what? To 0. So plugging t to 0, this becomes what? 0. So we only be left with what? 2 over 3 factorial. And 3 factorial is what? 3 times 2 times 1, and that's automatically 6. So we are left with 2 over 6. 2 here 1, 2 here 3. So that finally gives you what? 1 over 3. 1 over 3. We also have to find what? The variance, sigma square, don't forget. which is what? Which is your first moment or your second moment minus the square of your what? Of your first moment. And that automatically gives you what? What the second moment? Our second moment gives us 1/3 minus the square of your first moment, which is what? Which is 1/2 squared. 1/2 squared. If you do that very well, you should be having 1/12. And that's the final answer to that. That's the final answer to that. So we'll be solving one more example, which is the last example to this particular lesson. Example. This example says let f of x equals to 1/2 exponential minus modulus of x for minus infinity less than x less than infinity. Show that the moment derivative function, which is the expected value of exponential tx that we have run through, is equal to what? 1/1 minus t squared. 1/1 minus t squared. 1/1 minus t squared. Distribution. So as you can see, this particular expression is not a probability distribution, because your boundaries are giving what? Are giving inequality. So your x is what? Is a continuous. Your random variable x is continuous. So it's in what? It's a probability density function. So you need to what? Rewrite it in form of a probability density function. So rewriting this in form of probability density function, here we are having 1/2 exponential minus modulus of x. When you have a modulus of x, it means that x can be positive and x can be negative. X can be positive and x can be what? Can be negative. So let's see, when x is positive, what do we have? We have 1/2 exponential what? Minus x. And when x is negative, what do we have? Minus times minus. When x is negative, minus times minus, it becomes what? Plus. That will be what? 1/2 exponential x. 1/2 exponential x. So each of them are going to be having their what? Their boundary conditions. So the boundary condition of when it is exponential minus x is going to be what? x greater than or equals to 0. X greater than or equals to 0. And the boundary condition when it is 1/2 exponential x is going to be what? X less than 0. X less than 0. What this is trying to tell us is still about this condition. It's still about this condition we're given. This one says x is what? Is greater than or equal to 0. It means that we are moving from 0 to what? To infinity. From 0 to infinity, and this one says when x is greater than 0, that is we are moving from what? From minus infinity to what? To 0. We are moving from minus infinity to 0. And as you can see, we have 1/2 exponential minus x. 1/2 exponential minus x. In this situation, to introduce your infinity as boundary condition, the infinity x must be that infinity, everything here must be what? Must be minus infinity. Must be minus infinity for it to be what? For it to be mathematically defined. For it to be mathematically defined. That automatically tells you that what? Here you must be having what? Must be having infinity here. But in this situation, you must be having what? You must be having minus infinity. You must be having minus infinity. And x is already plus already. So automatically this will be what? Will be x less than 0. So So we are going to determine our boundary conditions. So now let's solve for solution. Okay, let's solve for the moment generating function. Let's solve for the moment generating function of what? Of random variable x, which is a function of t. So that gives us what? That gives us the integral from minus infinity to infinity of what? Of exponential tx of f of x dx. So that will give us the integral from minus infinity to 0 of what? Of minus infinity to 0 of this of exponential tx times f of x, and f of x for this condition is what? Is 1/2 exponential x dx plus the integral of what? Of 0. You know, we ended at 0, we started from 0 here, of 0 to to infinity, of 0 to infinity. X is greater than 0, x is greater than equals to 0, so we don't know where it stops. So it's going to be what? It's going to be infinity. This one is also less than 0, we don't know where it ends, so it's going to be what? Minus infinity. So this is what? Exponential tx times 1/2 exponential minus x dx. So by integration, this is a constant already. So we can decide to bring out the constant, and we can also apply the homomorphism to these two exponentials. So we have what? We have 1/2 as a constant, integral from minus infinity, or integral of minus infinity to 0 of exponential tx plus x, exponential tx plus x dx, plus similarly 1/2 integral from 0 to infinity of what? Of exponential tx minus x dx, exponential tx minus x dx. And we know, just like we have done in one of our examples, we want the situation whereby we be able to have exponential minus infinity, so that it can be solvable, it can be solvable. And in this situation, if you plug in, if you bring out, okay, let's bring out x first, 1/2 integral of minus infinity Here we have what? And going to infinity, we have exponential x into t plus 1. Exponential x into t plus 1. We factorize out x dx plus 1/2 integral from 0 to infinity exponential x into t minus 1 dx. So we've been able to simplify this, and as I told us that we want situation where we'll be having what? We'll be having exponential minus infinity. So if we introduce x as minus infinity in this situation, you are good to go in this situation, because x is already what? Minus infinity is already here already. So if you introduce minus infinity, then you are good to go. Let's check for this situation. But for this situation, will you be having minus infinity? You will not be having minus infinity. You'll be having what? You'll be having infinity for this situation. So you need to what? You need to rearrange this or manipulate this. So here we are having what? 1/2 integral of infinity of minus infinity to 0 exponential x into t plus 1 dx plus 1/2 integral from 0 to infinity. Here, how do we make x to become minus x so that we can be able to have minus infinity? So let's introduce minus. So So we have exponential minus x into, so we introduce minus into this. So this will become what? This will become 1 plus what? 1 minus, this is going to become 1 minus t. 1 minus t, because if you bring in minus back, this becomes minus 1 and this becomes t plus t. And this becomes plus t dx. Integrating this, we have what? We have 1 over 2. 1 over 2 into, we differentiate the index. After differentiating the index, we divide it by the result. We have what? Exponential x into t plus 1 over, if we differentiate everything here direct to x, we have t plus 1. So I left here with what? With t plus 1. We are left with t plus 1. From where? From minus infinity to where? To 0 plus 1 over 2 into, if you differentiate this as well, everything here you have what? Minus 1 minus t. So you have what? Exponential minus x into 1 minus t over minus 1 minus t. Minus 1 minus t. From where? From 0 to infinity. From 0 to infinity. So now let's introduce the boundary condition into that expression. Introducing the boundary condition into our expression. Introducing the boundary condition into our expression. So we're finally going to be having 1 over 2, which is a constant. We can also decide to bring out t plus 1. So we have 1 over 2 into 1 over t plus 1. 1 over t plus 1. Then we introduce the boundary condition into exponential x times t plus 1. So we have what? We have exponential 0 into t plus 1 into t plus 1 minus exponential minus infinity into t plus 1 into t plus 1 plus 1 over 2. Here we have minus, so we can bring out the minus here. So this can become what? This can become minus 1 over 2. Here we have what? Here we have, and we can also decide to bring out the constant as well, which is the denominator, which is what? 1 over, so this becomes what? 1 over 1 minus t, just like we have done here. So here we have what? Exponential minus infinity, because that is x, and we introduce, that is minus x, we introduce infinity becomes minus infinity into 1 minus t, so 1 minus t minus exponential minus into 0 into 1 minus t into 1 minus t into 1 minus t. So by simplifying further, we have what? 1 over 2 into 1 over t plus 1, close bracket. This automatically becomes what? Becomes 1. This automatically becomes 1 plus 0 times this becomes what? Exponential 0, and exponential 0 will give us what? Will give us 1. So this becomes what? 1 minus, this automatically becomes 0. Because we have minus infinity times this, it becomes what? Minus infinity, and exponential minus infinity becomes what? Becomes 0. So we have 1 minus 0. 1 minus 0 plus 1 over 2 into 1 over 1 minus t minus, this is minus 1 over 2 into, this becomes 0 because we have exponential minus infinity times this, it becomes what? Minus infinity, and exponential raised to power minus infinity is what? Is 0. This becomes what? This becomes 0 minus everything here becomes what? 0. Exponential 0 will give us what? Will give us 1 minus 1 minus 1. So let's simplify everything. This becomes 1, so this remains. Everything here becomes what? Minus 1. Minus 1 times minus, it becomes what? It becomes plus. It becomes plus. Minus times minus becomes plus. So I left it what? 1 over 2 into 1 over 1 plus t. T plus 1 is plus 1 plus t. Plus 1 over 2 plus 1 over 2 into 1 over 1 minus t. 1 over 1 minus t. So we can decide to bring out our 1 over 2. Bringing out 1 over 2. Here we have what? Here we have 1 over 1 plus t plus 1 over 1 minus t. So taking LCM, we have 1 over 2 into 1 plus t into 1 minus t. So we have what? 1 plus t cancels this, so we have what? 1 minus t. This cancels this, we have 1 plus t plus 1 plus t. So we simplify this further. This becomes what? This becomes minus t plus t. That's 0. 1 plus 1, that's 2. So this becomes what? 1 over 2 into 2 over. Then you can see this is resembling difference of 2 squared. Difference of 2 squared. That's automatically 1 squared minus t squared. And 1 squared is 1. That's automatically 1 minus t squared. 1 minus t squared. 2 cancels 2. So we are finally left with what? We are finally left with 1 over 1 minus t squared. 1 over 1 minus t squared. And that's the answer to that problem. So if you are new to this channel, make sure you subscribe and like and share the videos with some of the other colleagues who will also find the video helpful. Tutor Bosun is here. Thank you.